Welcome to Algebra 2. This is Chapter 2.8, Two Variable Inequalities. So instead of a number line inequality like we've been dealing with, such as x is greater than or equal to 8, where we fill in the circle if it's greater than, or where it's greater than or equal to, and if it's greater than, we move to the right. Another example, if x is less than 0, open or closed circle? It's an open circle and it's to the left. Okay, so that is one variable inequality where you're just dealing with x. Two variable inequalities is the same idea, except now you have a coordinate plane and you're going to have an equation such as y is greater than x plus 1. So you got to graph a line and then you shade. Okay, so in these examples, notice how we have a dotted line or a solid line. A dotted line goes with greater than or less than. Okay, so that's like your open circle on a number line. Okay, and the solid line, that represents your closed circle, where it talks about greater than or equal to, or less than or equal to. Also notice that there is shading. So if there is shading above the line, so above the line means that it is greater than. If there's shading below the line, that is less than. Another way you can determine which side to shade is to test a point on the graph. Easiest one to test is 0, 0. So plug in 0 for x and 0 for y. If it comes out true, then you shade where 0, 0 is. If it doesn't, then you don't shade that part and you shade on the other side of the line. So let's do an example. First step is to actually graph this line or equation. So I'm going to do that quickly while I pause the video. Actually, just kidding, I want you to see how I graph this. So this is slope-intercept form, so this is your y-intercept. So it's going to intercept the graph at a positive 1. And this is your slope of negative 2, so that means we're going down 2 over 1. So now we have 2 points that we can connect with a line. And that's our graph. Okay, but we're not done. Because this is greater than or equal to, our line should be solid or dotted. Should be a solid line. And because it's greater than, are we going to shade above the line or below the line? We're going to shade above the line. Okay, so just shade that quickly. I'm going to show you how to guess and check, just in case you maybe are doing your homework and you don't really know exactly what it should be. You can solidify your answer by plugging in 0, 0. So notice how 0, 0 isn't on the line, it's on this side. So we plug in 0 for y, and we're going to plug in 0 for x. And we're going to solve. So negative 2 times 0 is 0. 0 plus 1 is 1. Is this statement true? 0 is greater than or equal to 1. No, it's not true. So 0, 0 should not be shaded. So you're going to shade the other side of the line. Let's do b together. So b is the same exact line, negative 2x plus 1. So I'm going to graph that one quickly while I pause the video. Alright, so we have the same line. So now we're going to look at the inequality. It's less than, so first of all, should this be a dotted line or a solid line? Should be dotted, so I'm going to go through with my eraser and just erase some points quick so that you know it's dotted. Alright, and then next we need to shade. So because this is less than, are we going to shade above or below the line? Alright, we're going to shade below. And again, you can guess and check if you don't exactly know what to do. So we're going to guess and check 0, 0 again. So if we plug in 0, 0 into the same equation, we get 0 is less than negative 2 times 0 plus 1. So here we have 0 is less than, negative 2 times 0 is 0, 0 plus 1 is 1. Is this statement true? 0 is less than 1? Yes, it's true. So 0, 0 needs to be a part of the shaded region, which it is. So good job. Problem 2 is a word problem about having tickets for small or large rides at the fair. So actually currently while I am making this video, the Huron County Fair is going on. But anyways, so we have 3 tickets for small rides and 5 for large. So this one's small, this one's large. Each ticket costs 25 cents. And they tell you that you don't want to spend more than $15 on a ticket. So you only have $15 in your pocket. So we have $15. How many tickets can we get with $15? Yep, we're going to multiply $15 times, or we're going to divide, It costs 25 cents to buy a ticket. So we're going to divide the two. 15 divided by 0.25 gives you 60. So you can buy up to 60 tickets. So in my equation, can I buy more than 60 tickets? No. So my equation needs to be less than 60. Can I buy exactly 60 tickets? Yes. So I'm going to be less than or equal to 60. So we got that part of our equation done. Now we have to do the actual equation part. So we have 2 different rides. We have small rides and large rides. Small rides I'm going to give the letter X. Large rides I'm going to give the letter Y. How many tickets for each small ride? 3 tickets. So if you go on 1 ride, it costs you 3 tickets. If you go on 2, it costs you 6. 3, it costs you 9. Example. Okay? So how much does it cost for a large ride? 5 tickets. So 5 times Y, the number of large rides that you're going to go on. And then are we going to multiply these, add them, subtract them, divide them? We're going to add them, because if you go on a large ride and a small ride, you add the cost together to the number of tickets that you spent that day. So this is our equation. So now we're going to graph it. Easiest way to graph it is to plug in numbers for X and solve for Y, or plug in numbers for Y to solve for X. My favorite number to plug into an equation is 0. So when X equals 0, we need to figure out what Y equals. So 3 times 0 plus 5Y is less than or equal to 60. So 5Y is less than or equal to 60. Divide by 5. Y is less than or equal to 12. So when X is equal to 0, Y is equal to 12. So that's one point that we're going to plot. So I'm going to plot that on my graph. That point is right here. Now I'm going to solve for X when Y is equal to 0. So instead I'm going to solve for when Y is equal to 0, what is X? So 3X plus 5 times 0 is less than or equal to 60. 5 times 0 is 0, so 3x is less than or equal to 60. Divide by 3 to get x alone. X is less than or equal to 20. So when y is equal to 0, x is equal to 20. So that spot is going to be right here on our graph. So now we have 2 points we can connect with a line. And should this line be solid or dotted according to our inequality? It should be solid. Good. What side should we shade? It might be difficult to look at this and figure out what side to shade, so let's pick a point, 0, 0, and figure out if that should be a part of our shading. So when x is equal to 0 and y is equal to 0, what is your answer? 0. Is 0 less than or equal to 60? Yes, so that should be part of our shading. So we're going to shade down here under our line. There's another step to this problem though. Just because we have a side shaded doesn't mean that it's correct. So let me pick this point right here. Okay, that point is about, let's see, this would be 4. It's about 4.5 and whatever. Can you have 4.5 rides? No. So instead of an actual shade, to be actually correct, we need to plot individual points. So that's going to take a long time, and it's okay if you don't do it because I'm not going to finish this because that is a lot to do. Okay? But I want you to understand that there are those kinds of problems where the shading isn't actually correct. It needs to be dots. They need to be discrete. And got it, number 3, we're going to do this together. So we have a graph. Y minus 4 is greater than or equal to 2 absolute value of x minus 1. So first we want y alone, so we're going to add that 4 across to the other side. So greater than or equal to 2x minus 1 plus 4. This is a little bit of a review of absolute values. What does this 2 do to your graph? It's a stretch. What does this minus 1 do to your graph? To the right. What does this plus 4 do to your graph? Up 4. So we're going to graph that right here. So my original point is at 0, 0, but we're going to go to the right 1 and up 4. 1, 2, 3, 4. So that's where my vertex is. And then all my other points should follow, except now we're going to do a stretch of 2. So instead of going over 1 point, see how I go over 1? We're going to go up and over 2. It's like the slope changes. Alright, so that's our graph for this absolute value problem. And if you're confused on how I got that stretch out of there, write down the question and make sure that I answer it in class. Alright, and now we need to shade. So we have a greater than or equal to. Oh, and I'm sorry, greater than or equal to, should that be solid or dotted? That should be a solid line, so we're good on that. Now, what side should we shade if it's greater than or equal to? We're going to shade above the line. So when I say above the line, this is what I mean. On this line it's above, on this line it's above, so it's within our graph. Let's do got it number 4 to finish up this section. So it asks for what inequality does this graph represent? So we have a graph and we need to figure out the equation or the inequality. So to me this looks like an absolute value graph, right? It's a V kind of graph. So let's start with an absolute value graph. Again, this is an inequality. I don't know which way it goes right now, so we're going to use this. And we have the general form of this kind of function, okay? Where A stands for your stretch or compression, plus or minus H is left or right, plus or minus K is up or down. So our vertex is usually at 0, and we see that it's been transformed, right? It went over 1, well, actually that's -2 and -4. So it went to the left 4 times. So is that plus or minus H? It's plus H. Whoops. And we know what H is equal to. We just counted 4. And we went up how many steps? 2 and 3. We went up 3 steps, so that's going to be plus 3 in the K part. We don't know what kind of stretch or compression we have right now. So how do we solve for that? We're going to pick a point on the graph and plug it in and figure out what A is. So we're going to pick -7 for X. And our Y is at 0. We're going to solve for A. So go ahead and do that. To save time, I solved A by myself. So A is equal to -1, so we can plug that into our inequality. So we have a -1 absolute value X plus 4 plus 3 on the outside. So now it's your job to finish in your notes what inequality should go here. greater than, or less than or equal to, less than, greater than or equal to, or just greater than. That is